testing and continuous integration. For those of you who watched the previous talk, there will be some overlap. It's actually a really good talk, I think. And I concur with a lot of things that was mentioned there, so you'll see a little bit of repeated content, but that's not so bad. It's all good materials at the end of the day. So my name is Mats. I'm from Lund. As you can hear, I'm a Stockholm guy. I live in Stockholm now. I run a company called Bryntum, which makes Gantt charts made in JavaScript, kind of like a Microsoft project, ported to the JavaScript world. And just a brief history of how I ended up doing a lot of testing is that it turns out it's very tedious and hard to test your application in the web, because there's so many combinations of browsers, browser versions, operating system versions, time zones. Too many factors, the test matrix just became insane. And if you're one guy shop or two-person company, you can't really afford a testing team. And you also cannot afford to spend like hours or days testing before every release. So that's like how I eventually ended up doing a lot of testing. And we started out trying Selenium, but we didn't really like it, so we wrote our own. So the tests I will show you today will actually be done in our own testing framework that we call Siesta, but the principles are all really agnostic. It applies to whatever you use, Jasmine, Selenium. So that's the background of how I became a tester against my will. But now I quite enjoy it. I actually enjoy it a lot. So what we're going to cover today is just how you get started writing a simple unit test. Once you have written a unit test, you of course want to have machines doing that for you, so you need to learn a little bit about automation, PhantomJS, WebDriver. I'll show a small sample. We'll also talk a little bit about UI tests. If you write rich internet applications today, you cannot skip the UI tests. It's not enough to just test your logic, you also have to test your views. I'll show you how you can use an event recorder. Selenium has that, we have that. That's very useful to save time. We'll also talk a little bit about application tests and the challenges there. Once you know how to write your tests, of course, you're kind of halfway there, and that's where the fun stuff starts, because then you can automate and sleep longer on Fridays. So you start using tools like Jenkins, TeamCity, you worry about code coverage maybe, gather some statistics, time to fix bugs in average, and of course you want to do the cross-browser testing, so you might want to look at some of the new cloud testing services. So that's what we're going to try to cover today in a pretty rapid pace. Also, it will be a bit of switching to like live coding and real-world samples, not so many slides today to keep you awake. So more about how we handle code quality in our company. And we're very small. We're like 7 guys, 6 developers, and we don't have a testing crew, so we can't really afford. So we need really good help from our tools. So that's the background. So let's just start. How many of you are testing your JavaScript? Server-side? That's actually almost less from the server-side. That's the first ever. That's pretty cool. So basically, for those of you who didn't raise your hands, you're kind of like this guy, which is pretty cool. If you've seen this meme, it's one of my favorites. Feel free to laugh. And the why, of course. This is basically a repeat of the last talk we heard, but it doesn't hurt to repeat. So you become much more productive when you trust your code. You know what you can expect from it. You don't have to like open this file or go to the definition, because you know that the test from last night agreed. So you're much more confident in your code. And use frameworks like Angular, EXTJS, Prototype. They contain bugs, of course. As does your code, my code. That's just the ugly nature. And refactoring is one thing. You should never refactor and fear it, because then you will never touch the code ever. And code handover, anyone starting in a new company, you don't know what code you can check or fix without breaking the entire app. So that fear is something that's super counterproductive, at least to me. I don't want to be in that position again, where I don't have the confidence to change things. And of course, if you have customers, which I hope you do, then they obviously want you to, they don't want to report the same bug twice, because they'll start wondering what you're doing, right? And that happens to me a lot. So that's also a good idea to cover your bugs with tests to stop them from coming back. And also, we need a little bit of terminology, because tests mean different things to different people. That's pretty clear. So we need to discuss a little bit what tests mean. We talk about unit tests a lot, UI tests, application tests, black box tests, integration tests, functional tests. So we'll go through each one of those and try to discuss a little bit about those. And for prioritizing your test effort, because you can spend your time any way you want, right? So this test pyramid is what I try to live after in our world. We start covering our most important JavaScript logic classes first, because they get reused. If there's time over, let's go over the views, because we typically reuse maybe a customer list here, a user list there. They can be reused a lot, so that also has big value. And if there's even time and money left in the budget, why not do some black box application tests? So this is my sort of dream scenario, but what I typically find is that developers instead just spend some time doing PHP, Java backend tests, and if there's a little bit money or time left, let's do some Selenium on top of it. So this is kind of, we don't really have the same practices for JavaScript tests as we do for the server side. Because for the server side, we have very strong opinions that it has to be tested. It has to have like X% code coverage. I think we can also apply these principles to the front. So yeah, let's start with a look at unit tests. So a unit test should, of course, focus on a single unit, which in your world might be a JavaScript class, something that, so the unit test should not involve too many different things. It should just be isolated, very easy to understand what it's doing. Should not involve the DOM. It should be pure logic, like maybe math calculations, financial, calculating money, dates, stuff like that. That runs super fast, and you can run it over and over again, which makes it perfect candidate to put like in a hook, pre-commit hook, which is very nice. And this is kind of a repeat from last presentation. And then we added Jasmine syntax. This is very similar. This is the Siesta syntax. You describe, make it very easy to read. That's the whole point of this BDD notation that kind of Jasmine brought to the JavaScript world. So it should do something, and then inside of that subtest, you instantiate some user in this case, passing a name, and then you line up your expectations. And it should be, I don't know, maybe not possible, but almost possible for a non-technical person to figure out what you're actually after here. That's the whole point of BDD notation. So it might become a little bit more verbose, but that's a perfectly acceptable trade-off for test maintainability. And also the great thing about doing this, dividing your test into subtests with the if statements, is that you can turn them on and off. So Jasmine supports this, we support this as well. The IIT, which makes it the only tests run, so it will only run the tests marked as IIT. Everything else will be skipped. You can skip tests also explicitly using XIT. Similarly, you can do ddescribe or xdescribe if you're using Phantom. And this is great because if you have a bunch of these in a file and you see one failing test, you don't want to be delayed by having a ton of other assertions that don't really mean anything to you at this point. So then you just type that I, and then you're like zooming in basically to that particular test case. And that makes you very, very rapid. And you can run it over and over again and just iterate. So this notation is really, really good actually for speed. And this is, yeah, like the pyramid, you should start here, I think. Don't start with the Selenium test maybe, but start with the logic classes that you reuse over and over in your applications, like your library files basically. So because they are reused, which means that you get the most return on investment for those classes. And run these often because they're fast. They should not involve the DOM, so you can just run them over and over as many times as you can for need. So daily, before commits, before push, nightly of course. And yeah, if you can try to use the TDD approach, write the test first. Yeah, of course, the BDD is something I heavily push for as well, to have the test readable a year later, because that's when tests can lose their value, because if nobody knows what the test is doing, then you might as well delete it and start over. That's faster than just seeing it fail and not really realizing why. So just TDD basics, if you haven't heard it before. Fail, implement, make it pass, refactor, repeat. So it's a very, very simple paradigm, and the beauty of it is that you're forced to think about the implementation twice. As you write the test, you're like, what am I actually doing? There's no implementation, there's no skeleton, but I try to write the assertions and the expectations anyway. And that gives that brain an extra pass over your future code, which is nice. So I thought I should just switch over to my studio, which is WebStorm. Anyone using WebStorm here? Or IntelliJ? Yeah, same. It's a pretty good tool, I think, despite the JetBrains guys. And you can see here, I have a test file. This is pure JavaScript, by the way. Describe. It should be able to calculate a user total salary. And I have just a single simple function employee, which has a property called monthly salary and a name, for example. And then I allow the outside world to configure it. So the test basically starts by me creating a new employee. And I have an expectations that the employee annual salary should be 12 times the monthly salary, right? That's a reasonable assumption. So I switch over to the UI. This is how Siesta looks, by the way. And it's big and red. Hopefully you can see we got undefined. This is the first step of TDD. It's broken, that's awesome. It can get better, but as far as now, we're pretty happy. So now we can switch to the implementation. And since we're a lot of people in this room, we should be able to figure it out. Anybody cares to help me here? Return. Any ideas? This. Salary times 12 maybe. Go back to the test. Now this section is collapsed because it passed. We can see here, expect this number to be that number. Everything's fine. We feel kind of happy. Now that the test passes, we can of course refactor this. Maybe we want additional logic, some if cases, or just make it more complex. But now at least we have one test case guarding this method. That's good. And as you saw, when I'm checking the test, I'm just going back and forth between Chrome, between Studio, between Chrome, Studio. It kind of hurts in the hand after doing that like 5,000 times in a day. So of course you want to have some automated tool plugged into your IDE, and that's why we use PhantomJS for. Anyone using that here? It's a pretty awesome tool. So I have a key command. So right now I press it. Let's see. Yeah. So now it's running the same test on the command line instead. I don't have to go to Chrome because there's nothing to see. The DOM is empty. It's just a UI, but I might as well write it right in here. And I can screw it up and have some red color instead. Got 11, expect 12. And then I can just fix it, of course, and just iterate. And the beauty here is that I have it on a key command, so I don't have to move any hands or flip between views. It's just something that sits in your backbone, your mind. So just be able to iterate very quickly. PhantomJS is a beautiful tool. So phantomjs.org, free, open source, super nice. Heavily recommend it. So that is the unit testing. And then once you have a solid unit test in place, you can worry about maybe the next tier in your app. I'm assuming you write UI applications. There has to be a UI in your web anyway. And maybe if that's built using some complex framework, I don't know, Angular, Prototype, all these tools, then yeah, you need something to verify that those actually work too. And writing UI test, that's more tricky than doing unit test, because now yeah, you have to think a little bit more. It's much harder to do TDD, so you might have to like go a little bit back and forth and fiddle. So time becomes a factor when writing these tests. They're also, of course, much more fragile. We have dependencies now. We need to wait for the DOM. We have to wait for the DOM to be ready. That takes time. You can have race conditions. There could be like CSS animations that aren't obviously asynchronous, but they can screw a little bit with the timing. So failures that are hard to understand. So you need to take this into account that this is a different beast to fight than the unit test. And yeah, of course you have to understand CSS a bit to be able to work with the DOM. That's of course expected, or XPath. If you use Ext.js, you need to understand component query. Different needs for different frameworks, of course. But yeah, CSS becomes a very important way to be able to target things in the DOM. That's stable. And we should also clarify that when I say UI test, I mean two things. I mean either a UI unit test, like take this user list, put it in a sandbox, and work with it, poke it, see that it does what we want it to do. And the other type of UI test is basically the application test, which is just open index.html, do a bunch of things to it. It's more of a black box test. But we'll start with the UI test and see how we can test our view. So for this test, I wrote just a simple Ext.js, which is a UI library for like Windows-looking kind of applications, rich internet apps. And I created something very simple, a login window, which is just like 30 lines of code, some sizing, some field label for name, password, and a button to log in. And then I created a simple sandbox to test this, test different features of this view API. I'll show you what it looks like first, maybe so we get an ID. So that's the sandbox there that you see on the right-hand side. Just name and password, nothing strange. And in my test, I just include this file to be loaded, the login window. And then again, I use subtests. I say it should be able to, it should support adding and removing CSS classes of this window. Because maybe some of your customers want a special styling, so you have to be able to have CSS classes on your window, right? So you can theme it easily per deploy. So I grab the element, for example, like this, get element by ID, and then I just verify has CLS, that's short for CSS class. And then I try to remove. I call an API method on my login window, remove class, which takes it out of the DOM. And then I call this has not CLS. I should expect this to pass. And I add it back in, verify that both add and remove works. And at the end, I should also be able to destroy my window, and I shouldn't see it in the DOM. That's also a pretty decent assumption. And I use a special not okay, which is just a false check. So this will, of course, return undefined now. And as you can see, I run this test now. Everything seems to be green, and everything just works. So now we're doing much more stuff than we did in the unit test. Now we're putting things in the DOM. So we have much more things to worry about. Dependencies, etc. It's slower, but of course it still has value. We shouldn't ignore it just because it's a little bit more tricky. So that's basically a UI unit test, you could say, or an integration test. But the API of the view, basically. So that's one way of testing views. The second one, of course, we could poke it. We could click here, type there. Again, we use more of an asynchronous chain. If you've used Selenium before, this will feel pretty familiar. So say click the name of field, type Bob, type Bob's password, click the login button, and then some command verifying that the login window disappears after login is complete. That's just something I made up. So this is again, sort of an integration test of a single view in your app. And of course, you can run this as well. You see the types, and then I made it just a set timeout of 3 seconds, and then the window destroys itself. You can of course run this as many times as we think it's funny. I think at least one more time. It's actually pretty fun. So let's do it. So that's another type of test. That's going deep for one view. It's not application, it's definitely not unit test. It's somewhere in the gray zone in the middle. It definitely has value if you have a rich internet app, of course. It doesn't really matter what stack you're on, but the type of test is pretty interesting. So that is UI unit test quotes. And next up is application tests. And yeah, this has many names: black box testing, functional testing of your app. Essentially, you just go to your index.html or your app.html. You have no idea what to expect because you don't see into the app, black box. Essentially runs all the code of your app. It could go to your backend, of course, because it is your app, it's your real app. So you have basically less knowledge of what you're testing. You just know that, yeah, it's probably running a lot of code. And the upside of these kind of tests is that it gives you a good answer to, does the app work or not? And for me as a developer, I tend to care less about these tests. This is maybe what the QA guys would care about, the manager who says go or no go to the release. This is the #1 prior for him, right? But for us as developers, I think we care about the previous types of tests that I mentioned. Because the more of those you have, the less value for these. And these are the most expensive to write. Most time consuming. You need to worry about databases. You need to poke the app to make sure that it's in the right state before you start. You can have the session timeouts. You have to worry about how do you handle logging. Also, they're slow. There's not something you run before every commit. That takes way too long. Developers will quit. They're also very fragile because in a web app, everything is asynchronous. You load some data, you animate something, you wait for the user to do some interaction. So race conditions will come and they will bite you in the butt. It will probably not feel good, depending on what you like. So race conditions, we fight a lot actually. So we have to learn how to wait for stable conditions. Never ever wait for like a second just because that fixes it. Because then next time the test runs, it's under heavy load, the server is slower than usual, and then that second is not enough. So we always want to wait for a stable condition, never for a hard-coded value. And once it crashes or once it does something that you don't want, then it's kind of like seeing a map from the most zoomed out level. You can't really see any details. Whereas with a unit test, you're extremely zoomed in. You know exactly where to chase because you're testing that's one file. But now we're running everything. So it has value. I'm not saying it's bad, but it's I think as a developer, I care more about the previous categories. But this definitely has value. And yeah, writing these tests become pretty hard as well to kind of write it without peeking at the UI. So this is where you probably want to use some type of event recorder so that you can click and type and create these tests a bit more efficiently. So recorder is awesome for application tests. Records clicks, types, drag, drop, whatever you do with your mouse basically. And the overall goal here is that you can have this used by a non-programmer. So maybe you have a QA team outsourced that should be able to at least get 80% of the way with your tests, test authoring, using a recorder, which basically means save time, save money, etc. So I'll show you how our recorder works. I have a simple application test. This happens to be one of our UI components. So this test just opens up one of our samples in an HTML page, which of course for us, this sample is basically our sales window, because we don't have sales staff, but we do put all of our examples on our website and hope that people come there, click, and hopefully it works. So this is what we call application tests. We have to make sure that these don't crash or have rendering artifacts. So if I want to record something here, I could fire up the recorder. I could just drag like that, and then have this played back like that. So you can see you can do complex interactions just by clicking and dragging and having a recorder monitor what you're doing. And when that's done, you can generate the code. We can put that in our application like that, which just tells, okay, drag, some CSS selector on the right hand side here, and the child offset where exactly, so we hit the exact same pixel. If you get rid of the offset, we'll just choose the middle of your target to be most robust. We can go back, close the recorder, just rerun. The test used to be empty, and now we basically recorded an action. We didn't really spend any time, we didn't have to think about it. We didn't have to use the component or the developer inspector to look at the DOM to figure out all these CSS classes ourselves. So finding a tool with a decent recorder, if you want to get heavy into these types of tests, that's a huge time saver. Otherwise you have to poke and peek review this so that these CSS selectors are stable. So you might have to annotate your DOM a little bit to make sure that the test becomes as robust. Maybe use IDs for stuff that's unique. Use known selectors. That's a bit of a different topic. But Recorder is a great thing for saving time. So that's basically unit testing, UI testing, application tests. Then one of my favorite things is that we can do monkey testing as well. Has anyone done monkey testing ever? Yeah. So the concept is just having the thought that you have like 1,000 imaginary wild crazy monkeys at your disposal. And they will just click around, do stuff that not even your grandma would, and just repeat and bash and just see if it can provoke any unhandled exceptions for free. And yeah, so basically you pay nothing and you have people or monkeys testing your app. So a little math exercise. Let's say you buy a fancy ecological bananas, 5 euros for a pack, times 0, nothing. It's very cheap, and that's why I fall in love with this concept, because you don't pay anything. And we have had super nice help from this. I think at least 25 bucks a year. Could also be that we're shitty programmers, which maybe we are. But it's also awesome because we're getting help without paying anything, and I love it. It's super easy. And I'll show you how easy it is. So in our tool, we have basically just a one-liner. You target something in the DOM. You could say, click this button. Click random places in this button, click random places in this div. And then, since I'm targeting everything here, I'm just going for the body. And this is how many interactions you want. So if you have a lot of time and money and servers, well, this will take like a couple of days to complete. So let's not do that. But it's a one-liner, and we use this for all our products. And this is the result. Monkey, go away. So now it's completely random what's going on. And we're hoping for here, or hoping, is that it will find a trigger an exception. It'll type, click enter at a place that we didn't expect. It'll drag something to an area that we would never test because it's not a normal person would never do that. But still, it should not find any exceptions. So a bad thing, of course, is that there's a bug in the application. Of course, foo is not defined, should crash. And there it crashed. And this is a nice thing. This breaks your build. You get an exception, you get a call stack, and monkeys, you don't have to feed them any bananas. They say good monkey. And this fails. So this is something that we have had so much use of, and it costs us nothing. It takes not even like a half second to type this. So extremely close to being free. So highly recommend getting to know the monkeys. And the concept here that I really like is that it's free, cheap, and you catch bugs with no effort. So there's more we can do here. Logging errors at your client. This is not strictly continuous integration, but I thought I'd mention it anyway. So if there's an exception on your website, what does the user see? Any suggestions? Correct?
Lots of choices.
Well, not so many. Either he sees nothing because he's in Chrome and he's not a developer, so he doesn't have a console open. Nothing. If he's in IE, he might see that little nasty triangle or a pop-up, depending on what settings his enterprise has. Or if you handle the error, then you probably show a prompt, something unhandled bad happened, contact support. So you have probably 3 options. But the most likely one is that if you don't have the test logging on your server, you won't see anything. So hit save, there's a crash, but yeah, so potential loss of data, etc. So that's pretty bad. So yeah, my guess, most cases will just be a silent error, and then once he discovers the data is not what he expected, he might send an email, and then you have to try to backtrace to see what it did. What did you do? What website? What page? What URL? So that becomes a very tedious way of chasing bugs at the wrong end. And what we can do is just to use the on-error hook available in every browser now for quite a while. Last 2 arguments are what you really want. They're only available in the most latest versions of Firefox and Chrome. But that error object actually has the stack. And that should make you very happy, because then you can automate it and just have that stack emailed to you. And then finding that bug is so much easier. And again, then you're kind of using your users as your monkeys. So they basically help you test your app without knowing it. Even, again, it's free. You can send them bananas, but it's probably a very strange thing to do. So for our world, this is, again, our showcase. This has to work. If somebody finds a bug here, our customers are developers, so they will definitely have the console open and see, okay, these Bryntum guys are really shitty programmers because it just crashes all the time. That's very embarrassing. So we have this turned on for all of our samples. So let's make this break. Let's just add a little bug here. Old school. So clicking this. Okay, that's a crash. Again, developer would see this if they had the console open. But good thing is, so will I. Now the internet is of course slow. Actually not that slow. So within, I think, a second, I have this. I know more about this than the client does now, because I have a lot of information to go. In just a second, it's emailed to me. It's put in an error database. I have the stack. We even record the clicks they make so that we can replay it in a test easily. We see the browser. We see the date, because the date could be a time zone issue, daylight savings. You never know. So we just log everything, window size. And this also takes like, I don't know, 5 minutes to set up. And then again, you have your users acting as an additional test team for you. Cheap, free, why not? So that's pretty awesome. And pre-commit hook, another thing on the same theme, finding errors early. So in your pre-commit hook, you run some tests, you do a JSON check, you verify that you don't use the IIT, because IIT means that you skip tests. You don't want to have stuff like that checked in. IIT is only for temporary developer use. So this is exactly what we do ourselves. Our product, we have a simple pre-commit hook. I assume many of you use Git. This is a Git pre-commit hook. We run JSON to verify that nobody should be able to check in a trading call or a missing parentheses. That's just way too low level error to screw up your colleagues, because when they pull, they'll waste time. That's not really fun. And then we scan all the test files to see if there's IIT in it. Not allowed to check that in. And then the last part, we run our unit tests because they're super fast. So we run a couple of thousand tests and delays the commit by a couple of seconds, but I find that's a very reasonable trade-off as well. So pre-commit hooks, again, free help to keep the code base clean. So that's kind of the testing aspect of this talk. And then once you have all that in place, kind of then the fun begins, because then you can have statistics, you can do code coverage checks, you can put it online in a TeamCity or Jenkins portal, and then you can show your team and even your customers that, yeah, the tests are passing, as far as we know. So the purpose of having continuous integration in the first place, let's repeat. We have automated builds. That's very nice for us as developers. We can just not do manual things anymore because we don't want to repeat. Run the test suite as part of our CI, of course. Every night when we're sleeping, machines are not. Very important. Finding errors early, that's what we all want. Keeps code quality high, keeps developers not quitting. We're motivated, we smile. I like that. And once you have that, you can have continuous delivery, which is also my biggest reason for being in this space at all, is that I can release pretty much every second if I wanted to. But at least I know when I can release. There's data backing me up. Test suite is green, we're ready, or red. And this is a very good place to be. When I started, I was very scared of releasing. I had like 6 months between each release, and I kind of forgot, what did I even do in this release? And it's like this big of a change log. And it's like, okay, I have to test all these 20 samples, I7, 8, 9, 10, 11. Yeah, not so fun. So we use TeamCity. We run our test suite every 2 hours in Chrome, because Chrome is the fastest and the best. And we run everything, including Iíll stuff, every night when we sleep, so that when we come to work we have fresh results. And we have, of course, reports based on those results. We have statistics, charts, code coverage, data. And we even actually put our TeamCity portal online, so that our customers can actually go in here and check themselves. So they don't have to ask us, like, is it safe to use the latest Nitro build? They can go in here, see, okay, so this one looks pretty good. This is okay, could be better. And see here, so this is actually on the public web. If you want to check it out. And again, I very much recommend TeamCity. It's a super nice tool. Easy to plug in reports, get statistics, see who changed what. So if there's a broken build, you immediately see who has checked in as good. That could be the culprit. Also, TeamCity is very easy to plug in like custom reports. So if you have time over someday, you might start worrying about code coverage. So this is another report that we get from Siesta, where we can go like per JavaScript file to see like what are we actually testing here. So you see some is green, some is red, some is yellow. And with code coverage, we don't really care about what's well covered. That has no value. We care about what's untested. This is probably what will keep you up at night. If you ship stuff here that's critical files of your application, of course you're worried. So code coverage is another cool thing that you can just get very easily plugged into TeamCity. And yeah, we've had very good use of this tool. So and then the last part I want to show you, of course, even if you come this far, there's one big piece, like the last level of a computer game, the biggest piece that's left. And that's figuring out, when you know, of course, WebDriver, you know, PhantomJS, that doesn't really solve the multi-platform problem. And now we're having, we have to make a decision. So either we set up our own virtual machine farm, which we did, and that's extremely painful. Huge waste of time, and yeah, I never want to do it again. But yeah, think about it. Chrome, Safari, Firefox, a couple of IEs, that's a lot of permutations. And yeah, so basically your test suite multiplied by 8, that's the total time that you have to spend. And yeah, I would not recommend doing this at all. So what we can do instead, that we do, is that we integrate with these tools called Browser and Sauce Labs. Anyone heard, please? Yeah. So they're basically testing in the cloud. Pick any OS, pick any browser combination you want, pay by the usage monthly, and you don't have to worry about setting up your own virtual machines. We've done a fair bit of blogging about these because we like them very much. And I'll show you how this looks on the command line. If you can read this, I hope you can. You see I launched WebDriver, which is our wrapper of WebDriver, and just pass in browser stack, my key. Please don't copy my key and password, but I have to do it to be able to run this. And I tell it run Chrome, and then now it's opening a VPN to, I think they're in India, browser stack. And I tell them I want XP, I want Windows, I want Chrome, and then it's feeding me back results using the exact same Siesta harness that you saw on the page before. This is now coming back through that VPN tunnel. Of course, it's slower. You will not use this for your unit test, but for your nightly builds, this is pretty damn golden. It doesn't get better. And then you can, of course, parallelize, so you can have 5 of these running at the same time to have your tests run much faster. We haven't gone that far yet because we haven't really had the need, but if you have the money in the wallet for it, go for it, I would say. So this takes away maybe the biggest pain of testing JavaScript in the first place, or testing web, because cross-browser testing is such a black hole of time-sucking. So that's pretty cool. That runs for a while, and then they get results. 188 passed, 0 failed. Took 25 seconds. I didn't run all my stuff because it's too too long, so I have a filter. So it only takes tests that match the store string. So that's what's going on. All right, so definitely recommend Browser Stack and Sauce Labs. And to sum up what we talked about today, prioritize your JavaScript unit test first. If you have time over, money in the budget, do some UI tests of your views, and do some application tests. Definitely do monkey tests because it's just free. There's absolutely no reason not to do it. Yeah, we talked about a few techniques to find errors early, pre-commit hooks, error logging, extremely easy, and then yeah, plugging that into your Jenkins, your TeamCity, or your TFS flow, just to have all that data. Basically do the same thing as what you do for your server code already. And if you want to know more, well, I'm here for another day, so come talk to me if you want to hear more about what we do. We have a blog, the TeamCity portal that we have can be accessed using that URL. And if you want to know more about the testing in the cloud, use those last URLs. And I also have to mention that there's a fika coming up by our sponsors in the Vinterträdgården. So that's in, I guess, 5-ish minutes.
Yes.
And those 5 minutes we can spend with questions or having more fika. Thank you very much.
Your Siesta system, is that very specific to test your product?
No, it's actually completely generic. It's made for web testing. So you can test like Node, jQuery, whatever that's web. We use it a lot to test our XJS code because that's a framework we use. But it's completely agnostic.
Is it licensed or
yeah, so it's a free version without that many capabilities. So basically, the automation features, the recorder, basically all the enterprise stuff that goes in the paid version. There's a fully working free version and a trial that you can use to get started and see if it fits you. So, I mean, if you've used Jasmine before, this is basically Jasmine plus Selenium and a nice UI along with it, and maybe JavaScript so that you can extend it. Because yeah, we felt a little bit locked in with Selenium, and we didn't want to use 2 tools, so we made 1 tool to do both.
The tool which you use to report the bug, what is the name of this?
That's actually not a tool. That's you mean log the error?
Login error to
Yeah,
the email.
Yeah, I mean that's just a small piece of window on error basically. So I put this online as well. This is window on error. And this basically just pushes it to some URL that you decide on using a neat little trick. Instead of firing up Ajax request and worrying about that, we just use the image tag. We don't even put it in the DOM. We just set the source, and then that's the most lightweight logging you can ever do. And then what we do on the server side, of course, then we just use PHP email, put it in a database that we never look at. But as long as you see it in the email, that goes out to all of our developers. So that now I think there's 5 people wondering what the hell is going on the live server. But I'll have to tell them on Skype after this that there's nothing to worry about. So then, yeah, this is basically just sniffing, like getting the date string from the user so we can see what time zone. Are they in India, in China? That matters. If you, like us, you do a lot of date calculations. So maybe they have a daylight savings transition that caused some strange hard to reproduce error. We get the URL, the window size. It can also matter if you have a responsive app, right? Then maybe the user list is here in a big window, it's here on a mobile. So if it's available, let's grab it.
The question is, why you send it through email instead of sending it through a bug tracking system?
Well, I don't know. I want to know that it is a bug first. I mean, in theory, it could be a guy like me just breaking the app for fun. So it's not a bug, but the email is what we need. Just instant notification. So now we get very few of these because we have got a pretty damn good coverage of the that, but in the beginning we had extreme usage of our users without them knowing it, which I think is just a beautiful way of doing it. So that's cool. This is also available. Yeah, very, very simple script. Not even 20 lines of code. And of course, you might not want to log additional errors. You might want to have a cap, so that if you have an error attached to your mouse move listener, you shouldn't like do a DDoS attack on yourself. That's also don't log to your production server. Log to a shitty server that nobody cares about, because otherwise this could backfire. Anyone else? Any questions? All right, fika time.
Vi gjorde fika och sen är det den